Very good morning, students. So again, this is another tutorial problem in heat conduction with heat generation. Let me start the problem. A small electric heating application uses wire of 2 mm diameter. You can imagine any electrical application like heater, water heater, or some element in the kitchen or in mechanical application also. Diameter with a 0.8 mm thick insulation having the thermal conductivity of 0.12 watts per meter Kelvin. The heat transfer coefficient on the insulated surface is 35 watts per meter squared Kelvin. Determine the critical thickness of insulation in this case and the percentage change in the heat transfer rate if the critical thickness is used. So they are asking about the percentage of change in the heat transfer. Assuming the temperature difference between the surface of wire and surrounding remains unchanged. So we have to assume that temperature difference between surface and the wire are same. So actually there will be a change. We have to assume like that. In the problem they given. Let me see the numerical now. The radius given is 2. 2 by 2 because we have to find out the radius. They are given diameter 2 by 2 which is 1 mm. So 0.001 meter and radius 2 which is equal to, we have to add 1 plus 0.18 because here this is the 1, this is the 2. We have to add the 1 plus this radius. So which is 0.0018 meter and thermal conductivity is 0.12 and heat transfer coefficient is 35. So critical thickness we know that K equal to R into H. So we find out the RC which is not known. This is 3.43 millimeter. So case 1. So they said we have to consider the heat flow through insulation use. Okay, when it is used. So we know the formula 2 pi L T1 minus T infinitive ln of R2 by R1 divided by K plus 1 by H into R2. When we substitute R2 and R1, we get the value as Q1 equal to 2 pi L T1 minus T infinitive 20.77 because T1 is not given, L is not given, T infinitive not given. We will substitute and get that value. Okay. In the case 2, what we do, heat flow when critical thickness used. The critical thickness used. Here also we substitute RC and R1, critical thickness we have found. We are getting the another equation which is Q2, 2 pi L T1 minus T infinity divided by 18.66. So, when we substitute Q2 minus Q1, we get cancelled the numerator value. Only denominator values are remaining. 1 by 18.6 minus 1 divided by 20.77 divided by 1 by 18.6. So this 18.6, 1 by 18.6 is nothing but Q2 and 1 by 20.77 which is nothing but Q1. So Q2 minus Q1 divided by Q1 multiply with Q2 minus Q1 divided by Q2 multiply with 100. We get the percentage of value in 11.6. We get the percentage of value in 11.6. So this 11.6 is the answer what they have asked here. So what they have asked in this, determine the critical thickness of insulation in this case and the percentage change in heat transfer. Percentage change in heat transfer rate if the critical thickness is used. So first they asked to find out critical thickness that we have found with the basic formula K equal to R into H, that is 3.43 millimeter, and percentage of change in heat transfer, that is percentage of change in heat transfer is 11.6 percentage, which is 11.6 percentage. So which is nothing but this is the percentage of change when we are using the critical thickness and when we are using the insulation thickness. So with this, I close the session. Thank you.